Let's try and solve this question next. What does the question say? Tan inverse 1 upon under root of x square minus 1 where mod x is greater than 1. Okay. Since mod x is greater than 1, you would realize that the substitutions x equals sine theta, cos theta will not work over here. Sine theta, cos theta are not greater than 1, they are less than 1. The mod x greater than 1 has a hint of maybe applying substitution related to sec theta and cosec theta. And also we get a similar kind of a hint from here as well. X square is, if x is sec theta, then this becomes sec square theta minus 1. Yes. Which can be further simplified to give us something very easy. Right. Why not do that? Let's try and solve this one. Yes. So the substitution that will make is x equals sec theta or sec inverse x equals theta. Which gives me x equals sec theta. Condition that we are given is mod x greater than 1. Okay. So mod x greater than 1 would imply theta lies in which interval? This will imply that mod x greater than 1 would imply x greater than 1 or x less than minus 1. Okay. The values of sec theta lie in the interval 0 comma pi by 2 union pi by 2 comma pi. So theta belongs to 0 comma pi by 2. Pi by 2 is open for sec theta, and moreover since it is greater than 1 not equal to 1, so 0 will also be open, union pi by 2 comma pi. This is the interval in which theta lies. Okay. Therefore tan inverse of, let's take a look at 1 over under root of x square minus 1. What is this equal to? This is tan inverse of, let's substitute the value of x. What is x? X is sec theta. This becomes sec square theta minus 1 and its under root. Tan inverse 1 over, this is what is this? Sec square theta minus 1 is tan square theta, under root of tan square theta will be tan theta. Okay, so this becomes tan inverse of 1 upon tan theta or tan inverse of cot theta. Pretty interesting. What will happen to this tan inverse of cot theta? If you observe carefully, tan inverse of converting this in terms of tan, that's also okay, that can be done. This cot theta can be written as tan of pi by 2 minus theta. So we will get tan inverse of tan pi by 2 minus theta, and pi by 2 minus theta, pi by 2 minus pi will lie in the interval minus pi by 2 to pi by 2. Yes, this will be the interval minus pi by 2 to pi by 2, wherein we can define very easily. So from here we can move in one direction, that is tan inverse of tan pi by 2 minus theta using complementary angles, and this will further be equal to pi by 2 minus theta, which is pi by 2 minus theta. What is theta? Theta is sec inverse x. Or you could have moved in another direction. What is that? You remember properties of ITF as well related to complementary angles. Tan inverse of cot theta, tan inverse of something is also equal to cot inverse, in terms of cot inverse is also equal to minus cot inverse of that something. Where theta lies in this interval 0 to pi, yes, that's the output in which the result of cot inverse should lie. So this is pi by 2 minus theta only. Cot inverse cot theta will be theta, and yes, this is pi by 2 minus sec inverse x. Oh, we are getting the same thing. We should be getting the same thing, right? Something which is there. So in this I have applied results of ITF related to complementary angles. Here I have applied results of complementary angles related to trigonometry directly. Okay, is that all? So that's the complete solution for this question. What's the benefit? Remember, what's the benefit of writing this whole expression as this simplified expression? Pi by 2 minus sec inverse x is further analysis, further drawing the graph, further modification, maybe differentiation as well. If all of those things are involved, then this function is relatively easier to tackle rather than this form of the same function, right? That's the complete solution and analysis of this question over here.